Welcome, ladies and gentlemen, to your last note guide of the trigonometry unit of Unit 6. The section 6.6, the last unit, is all about graphing sine and cosine, as you can see by the title. And the objective is that we're going to graph sine and cosine with different periods, which I'm going to explain what a period is here in a little bit, amplitude, same thing, and translations. With that said, a difference between this course and the next course, which is pre-calculus, is that we graph everything in degrees in this course, and in pre-calculus we graph it all in radians. The other is we don't introduce in this course tangent, cotangent, and secant. We do that and we hold off on that until pre-calculus. So it's really important, though, we do sine and cosine in pre-calculus, so it is going to be one of those things which we do extend, so it's kind of important to understand this at this time. So we have two main graphs, the sine and cosine, like I said. Together we call they're obviously waves, and a lot of things in, whether it's radio waves, microwaves, all the great waves, Wi-Fi waves, right, which is just a version of a radio wave. Anyway, is called a sinusoidal. So when you have a wave function, it is a sinusoidal graph. And so when you see that word, just know that we are just talking about a sine or a cosine. When you graph a sine or cosine, you always graph 5 big points. And notice this is the 5 big points of the sine, where you would graph the intercepts, those 3 right there, and the max and min, and then you would continue it on from there. But notice that the sine starts at 0, 0. That's really a big tell, and it's important to note that. When you're dealing with cosine right here, notice you're not starting at 0, 0, you're starting at the max, in this case, which looks like it's 0, 1, and then you're going down. Notice this is one full period, or one full cycle is another way to think about it, and this from here to here is one full cycle, or one full period, which is why it's saying that down here. Notice that in a cosine, in one full cycle, you have 2 intercepts and 2 maxes, 1 min. Sometimes it's the mins and maxes are reversed if that's been reflected. And then the sine, you have a max and a min, and then 3 intercepts. Okay, so here is the main general form of the sine function. And then this is the main general form of the cosine function. And I hope you recognize the h and k, because that is just standing for the shifts on the x and the y, just like it would be for parabolas or quadratics. When we dealt with I just realized we haven't even dealt with exponentials yet, but we're getting into that. It's all the same pattern, but everything you learned from first part A in Advanced Alg with that h and k general form graphing applies here as well. A is amplitude. We're going to kind of go through this pretty quick because I'm going to show you how to do it. Note the graph reflects over the midline when A is negative, so I'm just going to talk about it and then I'll come back to it. B is frequency, so that B value is a frequency or number of times a full period happens from 0 to 360 degrees. The way we actually calculate the period then is do this 360 degrees divided by the B value, which again is your frequency. H is your phase shift, which I love this AKA, which is the same thing as saying a horizontal shift, but with sinusoidals we call it a phase shift. And then the K is a vertical shift. And again, the K, if it's a positive value, you're going to shift it up, and negative, you shift it down. Phase shift, you just kind of keep in mind that when it's in the parenthesis, if you have that x plus a value, you're actually going negative, so you're going to go to left, and otherwise, if it's a negative, like x minus 5, you're going to shift to the right 5. So everything is very similar to what we have done in the past in math, but there's definitely some huge differences, especially that frequency and amplitude. I do want to say this is a pretty big note to notice. It says the period and amplitude affect the shape of the graph. So the phase shift and the vertical shift is just translating it. It's literally taking the shape and just moving it, sliding it around, I think is what you used to call it back in the day, where the period and the amplitude actually change what the graph looks like. So I wrote this in the hopes that it will help you know step by step what to do, because if anything, these just get overwhelming when there's just so many things coming at you at once. The first thing you want to do is determine the midline, then you draw your max and min lines, then you create a starting point, and use, decide, are you dealing with a sine, cosine? Because sine, we know we start with 0, 0. Cosine, we start at 1, 0 or 0, 1. And then you have to apply your phase shift or your vertical shift, or horizontal shift, I'm sorry. And then you repeat the pattern. And we're going to talk about this over and over and over again, so I'm not going to get too much into this right now. So we'll come back to these steps just to kind of get you familiar with them. And that's so that was just a lot of like reading and talking, but now let's actually do it, okay? It says let's graph the function on the graphs provided. Of course, this is no calculator. It's not horrible to make sure that you can use your graphing calculator to graph these, but ultimately when the assessment comes around, you're not going to have a calculator. The first thing I'm going to do, just to make it a little bit more straightforward, is I'm going to say, hey, you know what? We need an A value, we need a B value. Oops, I can do a little bit better here. A value, B value, H value, K value. By the way, in pre-calculus, we don't call them H and K, which I find weird. We call them C and D. I think it just goes along with the alphabet A, B, C, D. Remember, variables are just whatever we decide they are. That could be a smiley face for all we care. But anyway, A, B, H, K. I like the HK because it's consistent with what we've been doing. Okay, so A is the number way in front, which is right here. The B value is 2. The H, there isn't anything added into the X, so I'm going to say there isn't one. Or you could even say 0 if you want. And the K is also 0. Now, keep in mind, this is the amplitude, and this is the frequency. So this is telling me that there's going to be 2 full periods from 0 to 360 degrees. And notice that here's from 0 to 360. So without getting too fancy, it's going to have 1, 2 full cycles. Now, of course, we're not going to graph it that horribly because we actually have to graph points, but I just wanted to make sure you understand frequency of 2 means 2 full cycles within from 0 to 360. Now, I find that it's important to calculate the period as well. The period, again, is going to be equal to 360 degrees over the B value, which is 2. So we know one full period, one full cycle, if you want to think about it, it's going to be 180 degrees, which only makes sense because if 2 cycles happen from 0 to 360, that implies that 1 cycle is going to happen from 0 to 180. Okay, so notice we have a sine. I prefer graphing sines over cosine because they start at 0, 0, unless, of course, you have a horizontal shift or a phase shift. I'm going to first really push you to make sure you draw your midline. Midline is going to be, in this case, since there's no shifting vertically, the midline is going to be right here. And the midline just means what it's oscillating around. So here's my midline. And I will always draw this. This is not something I just start. It's something I always do, especially as they get more complicated. My amplitude means it's going up 3 and down 3. So it means from 0, it's going to go all the way up to 3. So draw your max line. And notice I'm drawing it with dashes because it's really not, it doesn't exist. Kind of like the asymptotes we draw with a dashed line and so on. So they don't exist. They're more for reference. So here's your max line. And then your min line is right here, and that's down -3 from that midline. So we're really looking at that this is 3 and this is 3. Oops, min line. Okay, so now at this point, and I'm just going to take a step back and make sure you see your steps. It says determine them and draw the midline, check. Apply the amplitude and draw the max min lines, check, we've done that. So again, the midline is really important to notice if there's a K value. That affects obviously where that midline is going to be. The A value affects where that max and min line is going to be. And now we need to determine a starting point. And notice, if we have a phase shift, which we don't, that we can now start at 0, 0. And then you apply the period and fill in the big 5 points, the intercepts, max, and min points. So let me show you what I'm talking about. I'm going to switch over to a different color. Let's go with blue. I know I'm going to start at 0, 0. There's one of my points. I need to have a max point, a min point, and my intercepts. So I know that, again, my cycle is going to go from 0 to 180, so since it's a sine, it's going to end there. I know there's going to be another intercept in the middle because of symmetry. And my max is going to be right here, and my min is going to be right there, because everything is very nice and pattern-like. So then notice, you know, I'm going right to the max, going to the intercept, going to the min, going to intercept, so this must mean a max, this is the intercept, this is the min, this is the intercept. So you continue that pattern, and sometimes I go too fast and then I skip a point and everything's off, and that drives me crazy. So right now the blue is one full cycle, but you would have to, or one full period, but you would have to continue this along your whole, oops, I missed my, I can do better, through the whole graph. But I do like starting with that first cycle because that makes it understandable a little bit more. So, and sometimes I even highlight my first period just to really kind of see what it looks like. Okay, so that's like the guts of it. That's pretty basic, but it's a good starting point. So let's go to this one right here, example number 2, and start listing off the information that we need. And I'm going to continue with my color coding here. I have A is going to be 4, so my amplitude is 4 this time. I have a B value of a half, which means that I only get a half of a period, or a half a cycle between 0 and 360. So usually a full period is from 0 to 360, but I only get half of it. I also have a cosine, keep that in mind, which I already told you is not my favorite, but h is equal to 0 and or none, and there's no k value. So there that is. And let's calculate that period really quick. The period is going to equal 360 divided by that 1/2. And of course, when you divide by a fraction, like 1/2, you're actually doubling. So this is the same thing as saying 360 times 2, times that reciprocal. And so you're talking about a 720-degree period. And that's really from here all the way to here. So you're only going to get one period in that whole cycle. Okay, here we go. So let's draw a midline, which I know we have no k value, so I can put it right there, and I know my amplitude, 1, 2, 3, 4, is going to give me a max line of this, and my min line of -4. So here's my min, here's my max line, and here's my mid. Okay, so now, since I don't have an h or a k, I don't need to worry about shifting, but I do know I'm going to start right here. Oops, I'm going to shift colors here. What did I do? I went to blue, right? So I start right here, and typically, and don't draw this, but typically your graph would have looked like this, one full cycle. That's not going to happen because it's stretched, if you want to think of it that way, but that means that we are only going to get down to the minimum right here. So we're only going to get halfway. We start at the maximum, halfway we get to the minimum. If you want, look at that original cosine function up here, the parent, if you want to think of it that way. So notice usually we start at the max, and at 180 degrees we're at the minimum, and we're at the max again at 360. So we are only going to get to the minimum. And so now use symmetry, so I know that this here is going to be my intercept, and you have to make sure you draw it with that curve in it, okay? There's no corners. These are not absolute value functions, so it's important to graph them like sinusoidals, which are wave functions. And I could even do better. Watch, I'm gonna do it a little bit better. Okay, and so of course I'm above my max line, which isn't so hot, but okay. And so I'm gonna follow that pattern. So here and here, and there is my amazing shape. Now really, again, if you think about frequency, that frequency, which is a half, see, you only, I don't know what I just, I erased it, sorry. That's you only had a half of it from 0 to 360, where here, if you want to do it that way, you notice that from 0 to 360, you actually have 2 full cycles, which is why this is 2. You only have half of the period, which is why that B value is 1/2. or the frequency is 1/2. So it's just kind of good to see those patterns in everything. So example number 3, and really I'm going to kind of book along here so I don't lose you with boredom here. So I'm going to list out my values. You'll notice the pattern here. A is equal to 2, B is equal to 1, because there's nothing right here, so that's 1. Oh, finally we have an H value, which is 45, not negative 45 degrees, but 45 degrees. And again, look at that parent function. It's x minus h, just like parabolas. And then the k, we have a k value. Yay! I'm going to put that right here, even though I'm kind of encroaching in my graph. K equals 1. So this is kind of interesting now. So let's first figure out our midline. Ooh, not negative. Look, I just put 1. Ooh, I was looking at my graph and my key, and I'm like, that doesn't make sense. And then all of a sudden I look up and I'm like, ooh, I forgot my negative, and that's kind of a big deal. Okay, so notice it's minus 1, so that is the k value is negative 1. What does that mean? Well, instead of being on the x-axis for the midline, I'm shifting it down 1. So here's my new midline. This is kind of fun because we haven't done this yet. My a value, my amplitude, is 2, so I'm going to go down 2 from that midline. So there's my minimum. And then I'm going up 2 from that midline, and there's my max. And now I need to recognize that it's a sine, so typically I would start right, ooh, you know what, I messed up my max line, didn't I? Hold on, bear with me. I went up too many units. I went up an amplitude of 3. Let me try that over again. 1, 2. See, usually if I'm teaching in front of kids, they'll say, Miss Botkin, you made a mistake. And I'm like, oh, thank you, thank you. Okay, so here we go. Now, we know we're starting at 0, 0. Originally, I mean, of course, we're going to have to, I'm going to switch this over to green. Usually we would start right here and start from there, but, and what's nice, again, is if we didn't have the shift, I could have just said, hey, you know what, I know I have one full cycle like this, but because I have this phase shift, this right here, I need to not start at 0, 0, or I shouldn't say 0, 0, but the 0 on, you know, of course it used to be here and it's shifted down, so it's all these different movements, right? But I'm starting here, but I have to shift over 45 degrees. So instead of starting here, I'm going to start here on the midline. So let me kind of erase the other green one so I don't get you confused. So I'm starting right here at 45 degrees, positive 45 degrees on the midline. So it's nice to have that midline because that's really where you're starting with the sine. And then because our frequency is 1, which is nice, we know that we would have typically ended at 360, but now we have to kind of think about this. So it's usually skip 1, you have your maximum, skip 1, you have your, like when I say skip 1, I should say 45 degrees, and then you come down to your midline, and then you skip 1 and you're down to your minimum, and then skip 1 and you'd be at your midline again. So really we're kind of like right here at the very end. And this kind of messes with people's minds a little bit, but the counting technique works, I don't know, it works for me, but skip 1, I'm down to my minimum, skip 1, I'm down to my, or up to my intercept, skip 1, my max, skip 1, minimum, and then the same kind of thing you're ending up here. So if I graph this little fella in here, and again it should be a nice, smooth, rounded, no sharp corners, wave with, and I can't stress this enough, you need to plot those points. You have to plot the 5 points. Usually some teachers make you actually label them. I do not do that, but if you don't plot them, that means that you are not doing what you need to do. Okay, so again, if you're, that is the full like expectation, right? What I just did in example number 3. And if again you're highlighting stuff, keep in mind this is really like the full kind of like what you're working with initially, and then you're building it from there. Okay, so I'm gonna get a little bit more fancy here. Example number 4. We have 2 more graphs, and then I'm gonna let you go here. Let me switch it over here. I have an A value of -1. We need to talk about that because that's kind of important. B is equal to 2. The H value is equal to negative 90 degrees. Again, it says plus 90 degrees, but of course we know it's the opposite. And the K value is nothing. So that's nice. So we don't have that. Now, this, I'm just going to say, if I ask you what your amplitude is right now, you, I hope, will not say -1. An amplitude is always positive, that value, and you would say, hey, my amplitude is 1. The negative just means that it reflects across, as it says in that very beginning stuff, the x-axis. We also know here that the period, because we have two periods in one 360-degree time frame, or another thing you can think of is that you have 2 cycles in 300 from 0 to 360, so you have a period of 180 degrees. And you can use the formula, of course, that I showed you, but that's that. Okay, so let's calculate or put the midline in. Notice we don't have a vertical shift, so my midline is right where I want it to be, right there. And then our max line is going to be a period of 1 up. And you could always change the scale. I'm not going to because it'll just, but I'm just letting you know if all of a sudden on the y-axis you don't want it to go up by 1s because it's too squished, you can go up by halves or by quarters. In this case, it would make it kind of nicer to graph it, but here we go. Okay, so I really stress the max, the min, that's the mid, and then the min. There we go. And we have a sign, thankfully. And so we're starting at the midline right there. Oops, let's color code it because I can, right? Hold on, wait for it. There we go. Right here. Notice I don't have a vertical shift, but I do have a phase shift. So I put this here initially, but I know that I have to think about this for a minute because this is where I would start if I didn't have this. So I need to know that I'm shifting back 90 degrees. So this point, purple point now should be right there. Now, of course, if I erase it, give me a minute. Hold on, wait for it. I can't seem to erase it. Sorry, you guys. There we go. I'm just going to do that. Okay, so our beginning point, if you want to think about it, is right there. And now usually with sine, we'd go up to the max and then intercept down to the minimum. So we'd usually do this, right? But we're not doing that because of this reflection, because of this right here. So instead of going up first, we actually are going down first. So what's nice is that we have, we have to make sure we remember our period too. We have from 0 to 180 degrees is our full cycle. So if I scooched back 90 degrees, I know my full cycle is going to end up right here because it's going to be 180 degrees from the starting point to the end point. And again, instead of going up first, it's going to go down, intercept, max, intercept. This is my little puny original first period or cycle. So now I would continue that. Go minimum, intercept, maximum, intercept 2. This isn't so bad, right? It's almost kind of fun. Students either love or hate it, I gotta tell you. And as long as you have like a direct steps, it tends not to be too bad. Okay, so there is the graph. And again, if we want to just focus on that very first cycle that I had done, it was right here. That was the very first thing I graphed, and then I extended it from there. Okay, the last one must be really, really bad, right? Nah, it won't be any big deal. You watch. The A value is 3. The B value is 1/2, which means our period is a big one. I'm not too fond of big period ones because you don't get I don't know, it's fun when you get lots of little waves like that, but 720 degrees, you're only going to get one cycle in there from -360 all the way to 360. The H value is -90 degrees, and we have a K of 2. And you know what? I am not going to have room right there, so I'm going to put the K value right here. So I'm looking at the K value, which is 2. That means that's where my midline is going to begin. I have an amplitude of 3, no reflection, but an amplitude of 3, 1, 2, 3. So I put my max, there's my max, there's my mid, and 1, 2, 3, here's my min. I remember when I first started teaching this, I did not teach it with the max, min, and mid. I actually would have students draw the parent, and 1, 2, 3, 1, 2, 3, and do the multiples. Like there end up being like 5 graphs on one graph, and it worked for some kids, but I find this works for the mass majority. So just keep in mind there's more than one way of teaching this. This is kind of how I find that it works the best. Okay, so I took this into consideration. I took the k-value into consideration. I need to remember again that we have this period thing happening, or the frequency is only 1/2. And I am not starting at, hold on, let me go. I'm not starting at 0, or typically I would start here because it's a sine, but I'm going to again have to shift back to 90 degrees. So let me first get rid of that original green point, and let me put this right here. So that's my taking this into consideration. Now here's the thing, usually, and again you're going up, so usually this is what it's going to look like, but because of that frequency it really messes things up. So instead of skip 1 max, skip 1 down here, skip 1 down here, and do that, you're going to have to skip more because of the size of this. So you're actually skipping 1, 2, 3, 4 to get to the max. Let me make sure I got that right. 1, 2, 3, 4, because you're making everything stretched out so much. 1, 2, so you're not even getting there. You're going to end up where about right here. Okay, so let me just kind of keep going. Well, let me just draw this first. And I didn't even get to the minimum, did I? I was almost there, but not quite. And then here, 1, 2, 3, 4 is the minimum. And then I'm starting to come back up. Where am I going to end up? You know what I'm going to do? I'm going to mess with the rules here. I'm going to create another thingy. Hold on. Just so that I feel like I have a finish. Because 1, 2, that's not going to work. Yeah, let's just leave it. Never mind. Okay, so I'm going to end up about right here. It's not entirely accurate, but there we go. So notice 1, 2, 3, 4. I'm kind of missing my 5th point, which is kind of freaking me out, but you know what? That's kind of what happens when we have the 720 ones. So again, what I started at that -90 and did this part first, and then I worked backwards to finish that rest of that curve. So I hope that that will make this a pretty easy kind of concept. Notice the practice starts right here, and I'm trying to look. You know what? I'm going to have to upload, it looks like, the answers to this section. Notice that I did upload the answers to that section 6.5, the unit circle, as a scan copy in where it says Unit 6 packet, practice packet. So you're going to see the answers for this as well in that same kind of capacity. So again, notice really the instructions for that practice. This is for each graph, state the amplitude, frequency, period, phase shift, and vertical shift. So you can do like I did A, B, H, K, but then you need to make sure you actually physically state what the amplitude is, label what, point out which one's the frequency, what the period is in respect to the frequency, obviously, and which one's the phase shift and the vertical shift, so that I know that you know what those letters actually mean. And then, of course, graph the 5 big points, the midline, and then the max and min points, or lines. So again, no calculator, and I'll upload those answers as soon as I can. So good luck, and any questions you have, I will answer them. Take care.